Hello and welcome to this session. Get two targets with one Appium script. Tips to write robust and faster app tests. I am Hemant Ojha. I work as a software consultant for Utopia Solutions. You can follow me on Twitter, where I generally share my learnings and retweet the learnings of others. You can check out my LinkedIn and GitHub profile as well, and contact me on my email ID for further queries. So, what you can expect from this session? Here, I'm going to share the experience of a test automation team who was building a robust and efficient regression test automation suite for our product, which has been built to provide a similar or the same kind of experience for the users of both Android and iOS platform. Also, I'm going to discuss about some of the typical and some distinct challenges which we faced while creation of those suite, and and how did we overcome those obstacles? How did we thought through those obstacles, those problems? Our target was to create a test automation suite which consisted of around 200 test cases for a flight booking engine. It was a typical flight booking engine which lets users to search for the flights and typically book a flight with all the details. You can have a look at some of the pages of that application. Maybe the most important and the most or the longest scenario is the best fit for this demonstration or this discussion. We are going to book a flight. We are going to automate the test case for booking a flight where users might have to came across almost all the pages of the application to finally book the flight. And when he's using the application to book a flight, he might have to interact with almost all the possible controls available for a mobile application. So our goal becomes we have to create one product as a team and provide same experience for the users of both iOS and Android platform. And the goal for the automation team was to create one script which enables us to perform the execution on both the types of devices, both the types of platforms, I would say, and with minimum maintenance. We had to execute our test cases on multiple combinations of platforms and devices, and also had to make sure that we are choosing a tool in such a way that everybody is willing to contribute to the test automation specifically. So how would you approach? What would be your approach of handling such kind of project? We started with the POCs on multiple tools available that time. We we chose a small flow of the application and automated that flow with the tools like Calabash, Appium, Robotium, and Selendroid. After performing our analysis, we came to the conclusion that maybe Appium is the right product or the right tool to automate the test cases for our product or for the products in the pipeline. There were some factors which helped us in preferring Appium over other tools, which are first one is it enables us to write test cases in the language Java. It encourages more contribution because we have been already writing the test cases in Java using Selenium and Java for our web applications. So asking other QA members and other automation team members to write test cases for mobile automation was fairly easy. Appium enables you to write a single test or single test script for each test, which can be executed on both the platforms. It has a huge community support, so that if we get stuck with any issue, then maybe we will be able to find the solutions faster by getting the help of the community. Last but not the least, we had taken the good advantage of an open source library available on GitHub, which is Appium test distribution, which helped us in distributing in execution of our test cases in the distributed and parallel fashion on multiple combinations of devices and platforms. So for to use that, we actually had to set up a local device farm, but this library had helped us in performing executions on all those devices, plus reducing the execution time. So how does Appium works for our situation where we have to create only one script? How does it work is, when you write a script for a test case, that script sends the sequence of commands to Appium server. And then Appium server, on the basis of the capabilities which you are passing, forward those commands on either XQtest or automator for UI automator of iOS and Android devices respectively. Those frameworks on the respective devices perform the operation requested by the command and give the responses back to the Appium server, which in return the response back to the running JavaScript. And all this communication happens over a JSON wire protocol. Challenges? Yeah, challenges were the part of the game. I'm going to discuss about most of the typical and some of the unique challenges which we faced while doing this project. And we had found some challenges where we got stuck almost, but community helped us a lot in moving forward. And we are also going to discuss about the out of the box solutions which we found to overcome those challenges. So challenges are accepted. The first challenge which we found was Appium environment setup itself. We had to do the we have to make sure that we are able to execute our test cases from almost all the laptops available with the team. So we had to do the setup on both iOS and setup on both Mac. I'm sorry, for both the Mac and Windows platform. Doing the environment setup for Mac was a little easier as compared to Windows. Talking more about Mac, especially about the iOS real devices, we had to do more more configuration steps. We have to perform more configuration steps, because for to redirect your execution on a real device, you have need to have a developer license, and you have to sign uh, a web agent runner developed by Facebook to make your script execute on the real devices. Since we have already been through the struggle, and to make the life of the community easier, we have jotted down all the steps in a nice way in this gist, which can be used by any Appium user to do the setup on their respective Mac or Windows systems. Another challenge which we faced was giving another responsibility to the developers, which is helping the test automation team. So we asked our Android team developers to provide the resource ID to almost, or the unique resource ID to almost all the elements available on the page. Similarly, for the iOS team, we had asked them to provide the accessibility IDs to almost all the possible elements on the page. I would say almost all the possible elements, because sometimes they have to generate the elements dynamically, and for such situations they may or may not be able to provide the identifier to such dynamically generated elements. So that's okay. Here's the catch. We had to tell specifically to the iOS team members that you should only provide the value to the identifier of the accessibility and enable the accessibility, and you should not provide any value in the label and the hint. The reason for such kind of instruction was when you perform the get text operation while doing the script execution. So instead of the visible text on the application, it returns you the label which you have given over here. So always make sure that you are not putting any value into the label text box of accessibility. Another challenge which we faced is how we can manage the locators. How we can start with the objective of creating only one script to perform operations on both the platforms. We had followed a very typical page object model. So we have created pages and page objects for almost all the pages of the application. And this is how a typical page object page looks like, where we are using annotations like Android find by and iOS find by to locate the elements on the respective platforms by using a single variable. This helps you with returning the list of elements or the unique element as per your requirement. Another thing which slowed down our execution was handling pop-ups. It is very easy in the case of Android because you can just pass a capability and all the notifications can be, or all the pop-ups can be handled very easily. But in the case of Android, we cannot pass um, any capability to handle the pop-ups for us. So for iOS, you have to make sure that you are um, waiting for the optimum amount of time until the pop-up appears. If it doesn't appear, we move on. And also you have to be very acquainted with your application because pop-ups can appear anywhere according to the application's functionality. So you cannot use this, you should not use this method every time. You should anticipate the appearance of the pop-up and use this function. What this function do is it waits for the pop-up to appear for the next 3 seconds. So you have to find your optimum time on the basis of the speed of your application. Another challenge which we faced is interacting with the calendar. This was a very important step for us because we cannot book a flight without selecting the date. So our requirement was to select a specific date, any future specific date. Now, here we have implemented something called creation of dynamic locators. So how did we do it? Let's have a look at it. If you can focus on the string variable XPath, we are trying to create a dynamic XPath over here with the date parameter passed from the select date function. So suppose if you have to select the date 15, so by passing the string 15 into the function, it creates an XPath for you for the label which contains the date 15. And once you find the location of that label, you click on it and the dates get selected. Another thing which slowed us down was synchronization. Our application behaves on the basis of how much is your internet speed, how fast your backend is responding. So every application to fetch the data from the backend server, it has to wait for the content to get fetched. And this event can be easily distinguished by the visibility of a spinner on the application page. So how did we handle it? We actually had created a function wait for page load, which waits for the spinner or the loader to disappear for the next 2 minutes. We had to implement the fluent wait strategy over here. So, and we have used this function only at the locations where we anticipate the loaders. We should not use this function where you do not find any spinner or loader, because it is unnecessary. It is going to unnecessarily wait for the next 60 seconds and ultimately is going to fail. So you have to get acquainted with your application properly and anticipate the loader or spinner and apply this function over there. Generally, you can find such kind of activity while doing the page navigations or while contacting with the third-party applications. Next and very unique kind of challenge which we found here in our application is to select the seats for the user. The layout which you see on the screen currently is one of the layout which we faced while doing the booking. So on the basis of the seats availability and the arrangements of the seats in a flight, this layout changes. And our task is to find out the available seats and select the available seats as per the requirement. So ultimately we have to handle the dynamic grid. So how did we do it? On the basis of the properties of the available and occupied seats, we were able to get the list of all the available seats. And as per the requirement of seat selection, let's say if I have to select 2 seats, I iterate twice and click on the first 2 elements, or the first 2 elements returned by this locator. Another challenge which we found was interacting with the spinner or drop down. Spinner or drop down behaves differently for both Android and iOS platform, and for that reason Appium also has to handle them differently. For iOS applications, it was very easy to select any option from the drop down by simply setting the value. But for Android, simple set value doesn't work. So for Android, so for iOS, you can see we are finding the elements by using XQi element type picker wheel, and merely by setting the value inside it, we were able to select the year from the calendar spinner. But for Android, there are 2 ways. The first way is to spin through the options and wait unless you find the right option for you and move forward. And the approach which we had taken was to ask developers to make the spinner editable for us. It enabled us to edit the spinner at the time of selecting the value, and after editing the spinner, when you move on, the spinner accepts the value which you have just entered, and that's it. You have completely avoided the time which is going to be consumed by spinning throughout all the values. So just by editing the value of the spinner, it lets you to uh, select the right value in the spinner for Android. Yeah, and this is a very important uh, challenge, I would say, handling the keyboard. So while entering the text into a text box, the keyboard appears, and you might lose the visibility of the rest of the text boxes into the form. This makes your script a little bit less robust, because when you try to interact with the element which is not visible or just behind the keyboard, you won't be able to interact and your script will fail. So you have to make sure that when you try to enter the value in the text box, especially in the case of the small screen devices, you are minimizing the keyboard. There is no direct function available to minimize the keyboard given by Appium. So we have created a function to hide the keyboard. So how does it function? For Android, it sends an ADB commands, and the command response gives us the idea of whether the keyboard is visible or not. If it is visible, we minimize it. If it is not visible, we just skip it. Same for the iOS devices application. This situation can also be handled by using a simple try and catch block, but we don't prefer, because if the keyboard doesn't appear, we might have to wait for the script might wait for its visibility for that much amount of time, and our script execution time may increase. And the final challenge, and which we had to overcome, was to reduce the execution time. Recently, whatever I had discussed had contributed in some way or other by reducing the execution time. And one of the nicest way, along with the other ways, which we found to reduce interaction, is to avoid the interaction at all, and use the default state and default values of the application to interact with your application. So, for example, in the current screenshot, you can see the tab one way and round trip. So if your test case says that you have to go ahead with one way trip, then there is no need of interacting with the one way tab, because it is already selected. So this way you are actually saving the time of the whole cycle of Appium server and ultimately reducing the time for execution. So after implementing all these um, enhancements, or I would say or the out-of-the-box solutions, we found a significant reduction in the time of execution for both Android and iOS applications. As you can see, for we reduced the execution time for 50 test cases from 200 minutes to around 150 minutes, which is significant. And for Android, we got the reduction in the time of execution from 100 to 75. And we were happy after achieving this solution. We were happy after getting those solutions. So any questions are welcome, and if there are no questions, you can always contact me on my email ID, or you can tweet me on my Twitter handle. I would be happy to answer all of your questions. Thank you very much. Have a nice day.